All right, welcome everyone to part 5 of this video series on chapter 13. In this video, we're going to start talking about how we describe solutions and describe how saturated or unsaturated a solution might be. So to do this description, we refer to these things as concentration units, right? So we talk about the concentration of a solution, right? And that concentration can be relative, right? Unsaturated solution will have some concentration, saturated solution will have a different concentration, supersaturated solution would have an even different concentration, right? But this concentration values that we use describes how much solute is in a solvent. Okay. There are a variety of concentration units, and we'll go over a lot of these things in this video. Things like molarity, molality, mass percent, mole fraction, parts per million, parts per billion, so on and so forth, right? And there's a reason why there's so many units used, right? Sometimes it deals with the convenience of what we can measure in lab, right? Whether we can measure volume or mass or something else, right, can determine what we might use to describe a solution. Okay. Another reason might be because of the amount of things dissolved, concentration. Things like parts per million, parts per billion are your concentration units to describe trace quantities of something in solution. Because if you were to describe those same things using molarity and molality, you'd have a very small number. So it's a lot more convenient to write it in terms of parts per billion or parts per million instead of writing these extremely small numbers where you have like 0.00000000531 or something, right? Like, so it deals with convenience in terms of what we can measure in the lab, and then kind of convenience in terms of this actual size and actual amount of solute we have in solution. So the first one to talk about is molarity. It's a very commonly used concentration unit, especially in chemistry and chemistry labs. Okay. Molarity is defined as the mole solute divided by the liters of solution. Okay, so I want to just remind ourselves to make sure we keep in mind, right, molarity is dealing with the liters of the solution, right? The solution, right, is the solute plus the solvent. Okay, now often the solute has very little volume, and the volume, right, the liters of that solution is basically the liters of the solvent. Okay, but that's not always true. It's not always the case. Okay, but so it's key to keep in mind, right, that the liters of solution, right, is the total volume of that solution, and not just the volume of the solvent. Okay, and then there's molality. Okay, molality has the unit here, little m, often used. Okay, and so molality is given by the moles of the solute divided by the kilograms of solvent. Okay, and we got to remember that it's kilograms and it's of the solvent, right? So again, molarity has divided by the volume or liters of solution, while molality is the division of the mass or kilograms of the solvent. Okay, right. And then molality, right, we have no mass, while molarity, or sorry, no volume, while molarity uses the volume, right? And again, the difference between molarity and molality and which one you use often depends on what you can measure in lab, right? Let's say in lab, right, you can easily measure the volume of your solution, right? Then you probably want to use molarity to describe the concentration, right? But what if you can't necessarily, you don't have a nice graduated cylinder, you don't know the exact volume of your solution, right? But you can weigh it out, right? So then I can measure the mass of my solvent and the moles of my solute to calculate the molality, right? And so sometimes these things are more convenient than others to use in the lab depending on what experimental apparatuses you have available. Next, we'll talk about percent by mass. Okay, percent by mass is the mass of the solute divided by the total mass of the solution. Okay, right, so the total mass is, again, mass of solute plus the mass of solvent, right? And then, because it's a percent here, mass percent, we multiply it by 100, okay? Often the abbreviation for this is given by percent weight by weight, right? That's mass percent, right? Because you're taking ratio of weights and it's a percentage, right? And so that's kind of where that shorthand notation comes from. Okay, we then talk about parts per million. Okay, parts per million, often abbreviated as ppm. Okay, this is essentially the same type of thing as the mass percent, right? Where I'm taking the mass of my solute and dividing it by the total mass of my solution. But instead of multiplying by 100, we multiply it by 1,000,000, right? And that's why it's called parts per million, right? So it's a mass percentage, but it's multiplied by 1,000,000, okay? And then we have parts per billion, which is the same type of thing where it's this mass kind of ratio, right? Where it's the mass of our solute divided by the total mass, but now we're looking at multiplying it by 1,000,000,000, right? And it has abbreviation ppb, right? So again, parts per million, parts per billion, and mass percent all are the same ratio of the mass of the solute divided by the total mass. It's just one you multiply by 100, another you multiply by 1,000,000, and another you multiply by 1,000,000,000. Okay. There's parts by volume. Parts by volume is a volume percent, okay? And it's the volume of the solute divided by the volume of the solution. Again, we got to keep in mind in these different things, what is solution and what is solute and what is solvent, okay? And then again, it's a percentage, so you multiply by 100. And this often is abbreviated as percent volume per volume, right? All right, and then lastly here, we're going to talk about mole fraction, okay? Mole fraction is the moles of solute divided by the total moles, okay? So total moles, again, is moles of solute plus solvent, okay? Often given by the symbol X or chi, okay? You can talk about mole percent, where it's just the mole fraction multiplied by 100, but often we'll typically just use mole fraction, where again it's mole solute divided by the total moles. Okay, so this slide is just a summary, right, of these different concentration units of molarity, molality, mass percent, parts per million, parts per billion, mole fraction. I guess on this slide I didn't include the volume percent, right? Percent volume, right? And that's the same type of thing as percent mass. It's just the volume of the solute divided by the volume of the solution, right? And times that by 100, right? So again, we got to keep in mind here when we're using the solution versus the solvent versus the solute in these definitions, okay? We need to keep in mind what all these different definitions are, okay? So these different definitions you're expected to know how to calculate each one of these different types of concentration units, okay? These things would not be given to you in any type of quiz or exam, okay? So you are expected to remember these things, right? They're all fairly similar, right? And fairly straightforward, right? Their name tells you a lot about what you're looking at and what ratio you want, right? Each one of these things is a ratio, and it just depends on what is it going in the numerator and what's in the denominator, right? The numerator is either moles or mass of your solute, and the denominator can be mass, moles, or volume of your solution or solvent, okay? All right. And just one potential way to try to help convert between these different things is often this little 3-2-1 table, if you will, has all the information you need to solve for any of these concentration units. So if you're able to fill out this table where you write out what is the mass of the solute, mass of the solvent, mass of the solution, mole solute, mole solvent, and volume of solution, right? If you fill out this table, you'll have all the information necessary to calculate any concentration unit you might want, okay? So it's just kind of a convenient kind of way of organizing the data if you'd like to use it, but you don't have to by any means, okay? And often when we're trying to convert between concentrations, okay, sometimes you're not given, say, a total volume or a total mass of your solvent or solution or things like that, right? And instead, what we need to be doing is we'll need to just pick some fixed amount of solute, solvent, or solution to work with, okay? Typically, we want to pick some number that makes it easier to kind of do some of the math, right? You'll see a lot of examples of this when we work over different examples in class, okay? But just note here, right, that when you're converting between concentration units, right, the total amount of solution you have actually doesn't matter, right? Right, a solution is a homogeneous mixture. So I can have 10 liters of a solution versus 10 milliliters of solution, right? And they should have the exact same concentration, right? So the total amount does not matter. And so converting between concentration units doesn't matter upon the total amount, but it makes it a lot more convenient to do that conversion if we assume the total amount. Okay? And so that's it for definitions of concentration units and how we calculate concentration for different solutions and for this set of lecture.